Day 7. AWS log analysis. I'm speaking in CloudTrail. So much things. I'm mostly interested in the hacking stuff, not as much in the story. But okay. I'll read it. As SACMAS approached, so did the need to provide those with something to read. Care for wares tried, they made it their mission, a gift for all wares, a SACMAS tradition. Although they had some, they still needed more. To pick up some books, they head to the store. The town's favorite books would no doubt make them jolly. They ticked off the list and they filled up the trolley. The last book ticked off, the shopping was done. When asked for the card, the ware handed them one. "I'm sorry," he said, as the shop clerk replied. "I can't sell you these books as your card has declined." The ware put them back as they walked in confusion. How could this be an attack on intrusion? And when they logged on, the ware got a scare. To find the donation, they just weren't there. Right, I think there was donations before. Right, yeah, there was this talk about the website where people should select what they wanted, right? So we have a video. Monitoring in an AWS environment. Care for ware's infrastructure runs in the cloud. So they choose AWS as a cloud service provider, CSP. Instead of their workloads running on physical machines on premises, they run on virtualized instances in the cloud. These instances are in AWS called EC2 instances, Amazon Elastic Compute Cloud. A few members of the Werewolf SOC aren't used to log analysis on the cloud, and with the change of environment comes a change of tools and services needed to perform their duties. Their duties this time are to help Care for Wares figure out what happened to the charity's funds. To do so, they will need to learn about an AWS service called CloudWatch. AWS CloudWatch is a monitoring and observability platform that gives us greater insights in our AWS environment by monitoring applications at multiple levels. CloudWatch provides functionalities such as monitoring of system and application metrics and configuration of alarms on those metrics for the purposes of today's investigation, though we want to focus specifically on CloudWatch logs. Running an application on a cloud environment can mean leveraging lots of different services, e.g. a service running the application, the service running functions triggered by that application, a service running the application backend, etc. This translates to logs being generated from lots of different sources. CloudWatch logs make it easy for users to access, monitor and store the logs from these various sources. The CloudWatch agent must be installed on the appropriate instance for application and system metrics to be captured. I think I got a tiny fly in here, zooming around. A key feature of CloudWatch logs that will help the Werewolf SOC squad and us make sense of what happened in their environment is the ability to query application logs using filter parameters. Here are some CloudWatch terms you should know before going further. Log events. A log event is a single log entry recording an application event. These will be timestamped and packaged with log messages and metadata. Log streams are a collection of log events from a single source. Log groups are a collection of log streams. Okay, so the streams are built of events, the groups of streams. Log streams are collected into a log group when logically it makes sense. For example, if the same device is running services running across multiple hosts. CloudTrail. CloudWatch can track infrastructure and application performance, but if you wanted to monitor actions in your AWS environment, this would be tracked using another service called AWS CloudTrail. Actions can have those taken by a user or role granted to a user, giving them certain permissions, or an AWS service, and are recorded as events in AWS CloudTrail. Essentially, any actions the user takes via the management console or AWS CLI, the service will be captured and stored. Some features of CloudTrail include so CloudWatch and CloudTrail. Always on. CloudTrail is enabled by default for all users. JSON formatted. All event types captured by CloudTrail. CloudTrail will be in CloudTrail JSON format. Event history. When user exits CloudTrail, they will see an option event history. It is recorded of the actions that have taken place in the last 90 days. These records are queryable and can be filtered, or attributes such as resource type. Trails. The above mentioned event history can be thought of as the default trail. Included out of box. However, users can define custom trails to capture specific actions, which is useful if you have bespoke monitoring scenarios you want to capture and store beyond the 90-day event history and retention period. Deliverable. As mentioned, CloudWatch can be used as a single point of for logs generated from various sources. CloudTrail is no different and has an optional feature enabling CloudTrail logs to be delivered to CloudWatch. Okay. So a lot of stuff about how the logging works. And more. As mentioned, CloudTrail helps capture and record actions taken. These actions could be interactions with any number of AWS services. For example, service like S3, Amazon's simple storage service used for object storage, and IAM, AWS's identity and access management service, can now be used to secure access to your AWS environment with the creation of identities and the assigning of access permission to those identities. All of actions taken within their service are recorded. These recorded events can be very helpful when performing an investigation. Intro to JQ. Earlier, it was mentioned that CloudTrail logs were JSON formatted. When ingested in large volume, the machine-readable format can be tricky to extract meaning from, especially in the context of log analysis. The need then arises for something to help us transform and filter the JSON data into meaningful data that we can understand and gain security insights. That's exactly why JQ is and does. similar to command line tools like sed, awk, and grep. JQ is a lightweight and flexible command line processor that can be used. I'm gonna catch that fly. It just landed on the light and then it sped off again. So, flexible command line processor can be used. Yeah, we kind of got that at the header, right? So, my only problem with this is too much text for the meaning. They should just type it out in a not so long way. How can it be used? That's kind of what my notes. I'm trying to do everything just to the point. What we need to know, right? Not and examples instead of just talking a lot, right? Some stuff requires explanation. Some don't need the same amount. I'm thinking of my buffer overflow file is kind of low. Excusing myself. How can it be used? Now let's take a look at how we use JQ to transform and filter JSON data. The wheres are being the wheres being the wheres. They stored the shopping list from the trip to the bookstore in JSON format. Let's take a look at that. Book title, genre, page count. Okay. JQ takes two inputs. The filter you want to use, followed by the input file. We start our JQ filter with a dot, which tells JQ we are accessing the current input. From here, we want to access. I want to see what it looks like before I get details. I have still only seen a file. So we're just typing it like this. From here, we want to access an array of values stored in our JSON with the square parentheses, making our filter a dot square parentheses. Let's run the following command. So this nice list, we get this worse list from. Why would we want that? It's just formatting. It's just putting it on several lines so it's further to scroll. Well, we'll see. We're getting everything, right? So we'll probably filter it now. Yeah, so a pipe. Once we've accessed the array, we can grab elements from that array by going one step deeper. For example, we could run this JQ command. Book title, and we only get the book titles. If we wanted to view all the book titles contained within this JSON file, this would turn nicely formatted out. Okay. That's a lot nicer to look at. Isn't it? Well, it gives you an idea of what JQ. So if you had like a million different types of data and it was just scrolling around, we would like that, yes. JQ can filter and transform JSON data in many additional ways. It's our upcoming investigation we'll see in it. We'll see it in action. So, the peculiar case of care for where's dry funds. Now that we have refreshed our knowledge on AWS CloudTrail and JQ alongside McSkitty, let's investigate this peculiar case of care for where's dry funds. Responsible where for the care for where's charity drive gave us the following info regarding the incident. we sent out a link on the 25th of November to everyone in our network that points to a flyer with the details of our charity. The details include the account number to receive donations. We received money donations the first day after sending out the link, but they were known from the second day on. I talked to multiple people who claimed they had donated as a respectable sum. One showed his transaction, and I noted the account number was wrong. I checked the link, and it was still the same. I opened the link, and the digital flyer was the same except for the account number. McSkitty recalls putting the digital flyer Werewolf bank account QR. I'll just close my phone. It keeps having notifications. Yeah, the day after it was set out. Yeah, here. In Amazon areas, S3 bucket named Werewolf Care for Wares. Let's assist McSkitty and start by finding out more about the link. Before that, let's first review the information that we currently have to start the investigation. The day after the link was set out, several donations were received. Since the second day after sending the link, no more donations have been received. A donor has shown proof of his transaction made 3 days after we received the link. The account number in the transaction was not correct. McSkitty put the digital flyer on the yeah. The link has not been altered. Yeah, so it said there that it was altered. Whatever, why repeat stuff we just read? That's odd. Connection details. Now that we have enough information, maybe you could just read that and skip the rest, right? That's probably why. Let's start the attached virtual machine in this task by clicking the start machine button. And we don't know yet, but it said split screen. I had time to see this horrible check mark. Oh, there. So, split screen. Let's see what it says. Couldn't they just remove the split screen? The only thing I don't like about Dragme, especially when it's forced and when it's got a lot of people accessing it at the same time, right? So I'm just gonna scroll to the bottom and see we have 111,350 people in here now. So it's not increasing as much. It was 100,000 likes from the start. So Glitch did it. Yeah, it's starting there. Let's hope we don't have to do it again, because lots of people, you know. That's not Dragme's fault. Now let's examine the CloudTrail logs. Well, it kinda is, right? Related to Werewolf. Care for Wares S3 bucket. For a quick example, a typical S3 log entry looks like this. So, there. So let's full screen, throw it over to the other side, and minus this, so we at least can read it normally. So it might be overwhelming to see the sheer amount of information in one event, but there are some elements that we can focus on for our investigation. User identity. Yeah, we saw that one, right? It's username, but they said user identity. Okay, so they meant the whole thing. Okay. Event time, type, source, name, IP address, agent, and request parameters. So, what type of event? AWS API call or AWS console sign-in? Service event. From what service? What specific action? List object, get bucket object. So what was the event name of this one? We see that the type is API call. Here we have time, name, list objects. So let's check the user agent too and request parameters. So AWS SDK go. And request parameters is this bunch of stuff. Bucket name, host, prefix. So, by using the guide above, not below, we can read the example log entry as follows. The IAM user variable collector listed all object list object event of the S3 bucket named. The IP address from which this request originated. The user agent indicates that the request was made using AWS SDK tool for Go. Now that we know where to look, let's use JQ to filter the logs for events related to variable bank account qr.png S3 object. The goal is to use the same element to filter the log file using JQ and format the results into a table to make it more readable. According to Mosquito, these logs are stored in home variable logs directory. So I'm guessing we have stuff here on the machine. Now let's do the full screen here, right? So there are some bad things with that, but mostly I think it's positive. So F11 doesn't work, so we'll do full screen like this. If we go up here, it just keeps hopping and sometimes it disconnects. But we'll see. Fingers crossed, right? So let's look in the directory. Why do we have this so tiny? There. Yeah, it's at the bottom there. Oh gosh, that's interesting. It's not like I typed it differently this time. I was just typing LSLA and he got a million S's. Okay, so here we have the files. So to start, click the terminal. I can on the desktop enter these two commands. With the commands above, we initially changed our current directory to the directory Mosquito mentioned via the cd command. We listed it with ls. Now let's start investigating the CloudTrail logs by executing the command below. This is great for new people, right? They have all the details. It's not just saying, look at this file. So now let's start investigating the CloudTrail logs by executing the command below. Oh, the fly went for a sweep here and then went back again. If it had been there for one more second, I would have caught it. Maybe I should be like ready for it. Let's be ready for it. So do you think we can copy? This is quite a lot of text, and I'm not sure this is something I want to learn to do by just like that. Yeah, there's no paste, but we have this, right? So let's paste here. And now we have a paste. So okay, so JQ R R flag tells JQ to output the results in raw format instead of JSON. Okay. Dot records instructs JQ to parse the events in the records container event. The records field is the top element of the JSON formatted CloudTrail log. So I'm trying to click here. Come on. Okay, I can't click it. Select dot event source. There's a pipe too here. I don't know why I can't click anything. I had to do arrow, yeah. So equals. It's so tiny. Or whatever, I'll just ignore it. Tiny fly. You'll see me hunting all over the room. Now it paused by the camera, did you see it? I'll just ignore it. So event source S3 Amazon AWS.com and request parameter bucket name where will care for where's and then the file name, I'm assuming. So let's see. Uses the previous command output and filter it on the event source. And the request parameter bucket name keys. The value is just a filter event related to the Amazon AWS S3 service. And the value of where will care for where is used to filter events related to the target S3 bucket. So let's run the command before we do anything else. So we got a lot of information here. There, so we have here's event version. Here's where one starts, right? We can see, and here's another one, and hence a third, fourth, fifth. So 5 different ones. I'm kind of guessing they'll add stuff, right? As you can see in the command output, we were able to trim down the results since all of the entries are from S3. However, it is still a bit overwhelming since all the fields are included in the output. Now let's refine the output by selecting the significant fields. Execute the following command below. So here's the bit we already had. I'm just gonna scroll up on the other screen. So what we run here, and then we ended with the file name after this parenthesis. Now we're adding a pipe here. So this bit is the new bit. So event time, event name. Okay, so within the square parenthesis here, we're adding what we want. Why the NAs here. We'll read about it soon. Let's take the whole command to copy. So I'll call my 14-year-old. He can come in with a electric guitar. Say it's like a tennis racket with electric thingies. And catch the fly for me. Paste. So. Oh. Well, that can happen. Let's not paste the the prompt in there. So now we have the same 5 hits, but not all the data. It's filtered. So now you can see the IP clearly. You can see the time. It's like at the same time. 23, 25, 39, 39, 44 seconds. Glitch. NA glitch. Yeah. So these two have bank details. Okay, let's see what they say now. As you can see, we have appended another pipe to our previous filter. Let's discuss it quickly. Yes, we already read it, right? But it's interesting to see what this means. The pipe filter uses the previous command's output and formats it so it only includes the defined keys, such as did. The defined keys are enclosed with square brackets to process and create an array with the specified fields from each record. Note that the string //NA is included purely for formatting reasons. This means that if the defined key does not have a value, it will be display NA instead. Okay, right. So that makes it much easier to read. What if this... Well, would it have been nothing here? Or would the line not have appeared? The line must have appeared, right? So it just adds NA instead of nothing. Yeah, so let's find out, right? Let's remove those NAs. If it gives us an empty string, then I'm more happy with that. If it's not putting a line there at all, then that was very odd. So yeah, much prettier output. So as you can see in the results, we could focus on the... I mean, it's more easy to read by a glance if there's nothing there, or you had to read, oh, it says NA. It didn't actually say anything. We could focus on notable items, but our initial goal is to render the output in a table to make it easy to digest. Let's upgrade our command with additional parameters. So we got too little data. We need more. Oh, column. Well, I guess we copy it. So let's read this first. So the new command prepends the column header row and is defining the using square brackets since it's an array that responds to the selected fields. Note that the comma is used before the select filter to combine with those of select filter result we previously used. sets each array element. The output processed after the filters as a line of tab separated values. Column. It takes the output of the JQ command, now resulting in tab separated values, and beautifies it. Result by processing all tabs. It's not that I don't like tables, but with this amount of data, this is good enough. But if we had a lot of it more, of course we would possibly like this. So this is why I don't like this, right? The split screen. We have to do this for every copy and paste, and it's slow. It's just slow. And now the NAs are back. I'm not taking them away again just because it's prettier without them. So event time. So yeah, we already read all the data. They didn't add anything, right? No. Right, one thing here. The event name. I didn't read those. List object, list object, put object, pre-flight request. List objects. So I don't know what pre-flight request is. If it's like checking stuff. We'll see if we learn. Note, our crafted command lets us summarize S3 activities from our CloudTrail log. And now that we have crafted a JQ query that provides, isn't the Q query in this? Crafted a JQ, I guess we say then, right? That provides us well-defined output. Let's look at the result and observe the events. Based on the columns, we can answer the following questions to build our assumptions. How many log entries are related to? Which user initiated most? We already know, right? Which actions did the user perform based on the event name field? That's what we just read. What were the specific files edited? That's the image. What is the timestamp of the log? I should have this up, right? What is the timestamp of the log entries? What is the source IP related to these log entries? So, looking at the results, 5 logged events seem related to the... Well, I was going to answer them. And most are all related to the user glitch. Aside from listing the objects inside the bucket, the most notable detail is that the glitch uploaded the file Wearable bank account QRPNG on the 28th. It seems to coincide with the info we received about donations being made 2 days after the link was not. Well, it doesn't say. Mosquito was sure no user glitch in the system before, and there is no one in the city hall with that name either. The only person that Mosquito knows is the hacker who keeps to himself. Mosquito suggested we look into this anomalous user. Mosquito fooled us. Mosquito want to know what this anomalous user account is being used for. When it was created and who created it. Answer the command below to see all the events created to the anomalous user. We can focus our analysis on the following questions. So after we've already done a few things, and already before the event started, we knew that Glitch was a good guy. So it's a bit like, okay, right? But it could be that it actually was a glitch and he did good things, or it could be that the bad guy created the account to make it point at someone else. So we don't know yet. right? What event types are included in these log entries? What is a timestamp? IPs, tool OS. So let's look at the JQ here. Event time, event source, event name, username, source IP, and all the records select user identity name glitch. So we're selecting all the ones with glitch. And time, source, name, and identity is what we want to see, and they add the NA. They're just making the string longer for no reason. So I'm totally against adding stuff. It's definitely not making it easier for new people. I don't think so. I'm definitely new at this. So there. So this is everything that glitch did within this amount of time. And it's just these minutes here. It doesn't seem to be sorted even. So oh, so these are 1521. Let's see if it gives us a sort, right? That would be useful to sort them in time. I would like that. The results show that the glitch mostly targeted as your bucket. Notable event is console login entry, which tells us that the account was used to access AWS Management Console using a browser. We will need information about which tool and OS were used. So they're adding a user agent. So I guess we'll copy the whole thing again. Just when I hop to the other one, it scrolled a bit. So let's paste again. And make it tiny again. And paste for reals. And click. And now we can see the user agent here. And that's what they have here. Oh, by the way, we didn't actually look at this now. I was just hoping they would sort it on time. Since it is 15, 22, 21, 22, 21, right? So here's the console again. So is something wrong with my mouse? Does it scroll without me? Yeah, that was definitely a scroll. I think the mouse is going bad. Scrolls without me doing anything. So, this is a user agent string for the internal console using AWS. It doesn't provide much information. And then we have the Mozilla. It provides with two pieces of interesting information. It's used from Google Chrome, Mac OS. As expected, an experienced attacker can forge these values, but we could not dismiss this information. It can be valuable when comparing different log entries from the same user. We can park the current information for now. Let's gather more information to connect the dots. The next interesting event to look for is who created the anomalous user. We will filter for all IAM related events, and this can be done by using the select filter event source IAM Amazon AWS.com. Let's execute the command below and try to answer the following questions. What event names are included in the log entries? What user executed these events? What is the user's IP? So let's copy that. I might as well just click everything because it's what I have to do over here. That's the third click. So McSkitty. $53.94 is the same as this. Lots of list policies, get policy, create login profile, attach user policy. So, based on the result, there are many list policy events. By ignoring this event, it seems the most significant IAM activity is user McSkitty invoked create user action. And attach user policy action. Source IP. Yeah, same IP. User glitch use. Let's have more detailed look at the event created related to the create user. So now they're just doing create user. And we'll only find one thing, right? So I'm happy to paste this because it's a lot of typing otherwise. So here we have all the information. So what will be the next step? Based on the request parameters of the output, it can be seen that was user McSkitty created an anomalous account. Now we need to know what permissions the anomalous user has. Or isn't we're McSkitty, right? Like we're following along with our stuff. Now we need to know what permissions the anomalous user has. It could be devastating if it has access to our whole environment. We need to filter for the attached user policy event to uncover permission set for the newly created user. This event applies access policies to users, defining the extent of access to the account. Let's filter for a specific account by executing the below command. Another copy. I'm almost going to type. So So where's the information about that? Let's see what it says. Administrator access, it says here. I just saw it. Administrator access. So, McSkitty is baffled to see these results. She knows that she did not create. Yeah, that's we're like her, right? So, she did not create an anomalous user and did not assign the privileged access. She also does not recognize the IP involved in these events and does not use macOS. She only uses a Windows machine. All this information is different to the typical IP address and machine used by McSkitty, so she wants to prove her innocence and asks to continue the investigation. Logs don't lie. McSkitty suggests looking closely at the IP address and operating system related to the anomalous events. Let's use these following commands below to continue with the investigation. Just checking time. So, source address. Hi, welcome in, Producer Wolf. Thanks for hopping in here. Thanks for the raid. By the way, don't we have... What's up with the TTS? Did it die? Did it crash?
Connected to channel fix at 42.
That's odd. I know, I heard it when I started stream. Oh, and VR, you were there. Hello. I thought I had TTS on. So, Chrome must have crashed. Yeah, my computer is so stable. Never crashes anything ever. Sorry for ignoring chats.
Less than 3.
How are you, Producer Wolf? Hope you're great. So, we were just copying something, I think. Alright. I think I copied this, but
doing
I'm not
okay
sure,
coming
so.
in with a raid.
Yeah. Thanks for the raid. At these times it's good to have an auto shout out because what happened there? I don't know. Stuff. So now we can see whatever this this IP. So we can then notice the Mayor malware using the same IP here. So, and these are days before the 28th. So, we never would have guessed that it was the bad guy that did the bad things. Based on the command output, 3 user accounts must get English and Mayor malware were accessed from the same IP address. The next step is to check each user and see if they always work from that IP. Let's focus on each user. Okay. Replace placeholder with a name. So let's copy. Let's hop over here, and we have McSkitty, glitch, and Mayor malware to test with. No, we can't do that. We have to do this first. So, have you done any AOC? Any kind of AOC? So, when I was at my kid's school today, I do a little bit of Advent of Code instead. Because I do this on stream, right? So let's do... I'll probably want to continue that one on this computer because it's on a tiny laptop, and I was sitting actually in the car last bit with a laptop on against the steering wheel, so it's not the best coding environment. But I was in the library too first. But I had some extra time there when I was waiting for my kid. So, paste.
I mostly worked on the CCSE.
Oh, what's CCSE?
Colon.
Tell me, CCSE. What is it?
Only one more chapter to go.
Oh, nice. Yeah, right. We need to change the name before we get any data. There's no user called a placeholder. So let's go to a placeholder and let's put in. Okay, let's do Mexicity.
That's the certification I'm building.
Oh, cool. Cool. So you're almost finished with it. Can I do those things and test on stream? Should I do that?
Web link.
Yeah. I know I was in there before, right? I looked. Oh gosh, now we got this tab over there. I'm moving it to the other screen because this is the messy VM. Split screen one.
Pretty much. Sure.
So you're almost finished. Cyberhaven certified security expert. That's cool. Cool name. Yeah. So we can do this on stream, and we will still have it free. So we can click start now and get started. So maybe this is what the next thing to do.
It's all open to view.
Yeah. So 32 lessons, and you had one more coming, or one to finish maybe. So what happens if we click start now? Then we click here, and I don't know if I'm like
Hold up, getting
in.
that low.
Oh. I was like, am I logged in? Did I create a login? I don't know. You'll have to tell me when you're back. You tell me when you're back. Let's run this command meanwhile. So let's see. Here we can see that Mexicity is using 31.10 something here too. Not only that IP. So this is what they used before. And we know that malware used other stuff. So let's do glitch now. So are you're back, Producer Wolf? Was that long ad? Still going? So glitch.
I didn't hear what you said.
Yeah, I was waiting for you to come back. Yeah, so I don't know if I have like logged in here. Do I log in first? Do I just click the start now button? I did before. And I don't think there's like, I don't think I have a login, right?
Yes.
Yeah.
I'm back.
So now I just put my name here and email and stuff, right? Yeah. And then I click. So let's do that then.
You don't need to log in.
Okay, yeah, so I don't need to. Should I put something here? Don't you want me to? Oh look, now it says I have a password here.
That does not work. Go to name page.
Okay. Is this the main page? Or do you mean like here? Log in here.
View it under curriculum.
Under courses. Here. So here. But not now in the same place. Right? You have a cool site. It's cool. I like it.
No, the other one.
What? Yeah, I know there's a delay. I'll just wait here. Another one. Another link from here.
That was good.
I don't know if it was something I did long ago. Or something here. That I was supposed to click. Should I click courses?
Courses greater than CCSE greater than scroll down curriculum.
Okay, okay. So you mean here? Okay, so you mean show more items on preview. Is that the way to look at it? Hmm? So if we look at introduction here.
Yes.
Oh, so we see. So.
Yep.
It's not like I'm going to read it right now, but we can read it later.
You can just open them.
Yeah, so I can just click something else here, and it will hop here. And then it hopped. I scroll down nicely. Yeah. Great site. Did you build it all yourself? Hmm? So then we have associated security risks.
Yeah.
And I think everything at 360 minutes on it, right? Cool. Nice. Good job. And then we have a next button too, so I don't have to click on the side. I can click next when I've read that. I can read
There
this.
are 32 lessons.
Nice, nice. And see more sections. So I have to click this a lot though.
Next prev. Or next.
Yeah, exactly. There's the previous two, right. Nice. So that would you probably do, but if you would want to see all of them, yeah, or maybe you'd go back to the previous page to see them all there too. Cool. So you're almost finished. Nice. But it seems it's like it's reading, right? Is it all reading? Is there something else I'm reading? Here's this video. It's a YouTube link to a YouTube video. Okay. Yeah. Let's keep that tab up. Let's hop back to track me. Cool. Nice. So have you recorded videos for a lot of things there then? So let's just finish this thing too. We can do both at the same time. So this is not really.
Thank you, less than 3.
Intense. I'm just going to type mayor malware here instead of glitch.
I mean other people videos.
Okay, not yours.
Mine, haha.
Not yours. Because I thought that one was someone else's, right? Mayor malware. malware. Did we spell it right? What do you think? I didn't spell it right. Let's scroll up. Oh, lowercase and underscore. Okay. So I don't know if it's case sensitive, but we're still doing the underscore there. So mere malware. The account is only used from where is the IP? From this IP. As we assumed, right? It has to be the bad guy doing the bad stuff. He's stealing our money or changing the account number. We'll have to see more, right? While gathering the information for each user, we can focus our investigation on the following questions. Which IP, OS, right? Let's check the OS too, right? I'm kind of assuming only he will have Mac. And here's the McSkitty with the odd IP, right? Then it's a Mac only. And glitches. The fake one, or the new one, or the anomalous one, or whatever you want to call it, right? Based on the results, we have proven that McSkitty used a different IP address before the unusual authentication was discovered. Moreover, all evidence seemed to point towards another user. After correlating the IP and user agent used by each user, who do you think it could be? McSkitty has processed all the investigation results and summarized them below. Well, we have already read it all, right? Mere malware. Let's see, are we supposed to answer stuff here? What is other activity instead? Okay. So we're supposed to answer stuff here at the same time. Okay, now. So let's do those after we're done. We're almost done, I don't think. So we were here, right? Here. Incident starts with an anomalous login with the user account McSkitty from IP. Shortly after login, account grid created and given administrative permissions. It was accessed. This bucket replaced the PNG image, and this IP address used to log into glitch, McSkitty, and mere malware. And so their McSkitty uses several IPs and OSs. Just my phone not charging. So McSkitty suggests gathering stronger proof that a person was behind the incident. Luckily, Werewolf Bank cooperated with us and provided their database logs from their Amazon Relational Database Service, RDS. They also mentioned that these are captured through their CloudWatch, which differs from the CloudTrail logs, as they are not stored in JSON format. For now, let's look at the bank transactions stored in malware logs RDS log file. Since the log entries are different from the logs we previously investigated, McSkitty provided some guidance on how to analyze them. According to her, we can use the following command to show the bank transactions. Note, grep is a... yeah. So, from the command above, McSkitty explained that all insert queries in the RDS log pertain to who received the donations made by the townspeople. Given this, we can see in the output of 2 recipients of all donations. So, if we grep for the word insert in this log file, we will find a list of all the donations. Right? So we can type this. So let's see, can I switch screens? That's why I clicked my or unplugged my phone. Come on. There. Takes a bit of time. So let's grab insert RDS dot log. Grep is case sensitive, so now you can see who got the money, and it's kind of obvious who got the money, right? So we have Care for Wares Fund, and then it switches to Mayor Malware. So we're so surprised. So, as shown above, Care for Wares Fund received all donations until it changed into a different account at a specific time. The logs also reveal who received the donations afterwards, given the account's owner's name. With all these findings, McSkitty confirmed the assumptions made during the investigation of the S3 bucket, since the sudden change in bank details was reflected in the database logs. The timeline of events collected by McSkitty explains the connection of actions conducted by the culprit. So, yeah. So this person was reading really quick and typing to make the the image change just a few seconds before. It was a number in an image here, right? What is the other activity made my glitch aside from a list object action? So we're going to answer the question now. So we're getting a tiny peek into how this works, right? That's what we're doing. We're getting a tiny peek. So let's see what glitches stuff was. We had it listed up here, so let's just scroll up and look. Yes, love? So my kid's knocking. So my kid spilled some yogurt on the floor, so I helped him. So yeah, let's scroll up. Yeah, glitch didn't do a lot of things, right? So we can't scroll up all the way. What crap is this? Is it? I guess it's saving memory from this tiny thingy. I'll have to go up and rerun. Let's just go up to the top. So this is all the things that glitch did. It's like username glitch. What is the other activity made by the user glitch? Aside from list object. Well, right? I guess we try. How many letters? Bucket. Yeah, it must be put bucket. Oh, it's put object. Why did I'm like reading header bucket and put object and I'm mixing them. Yeah. Yay, we have a 1-day streak. What's the source IP related to the S3 bucket activities of the user glitch? So we just get the IP. I'm not switching for that. We're gonna type it even because I don't want to copy 53.94.201.69 because it's a split screen. That's why we don't copy. Based on the event source field, what AWS service generates a console login event? So we have it here, console login, sign in, Amazon AWS. So sign in dot Amazon AWS.com. And when did the anomalous user trigger the console login event? They want the full thing. I'm thinking if it's worth not typing it. Well, 11:28 T 15 colon. Odd to have colon in times. Colon 54. But I know. See, yeah, I've gotten these dates when programming stuff. What was the name of the user that was created by the McSkitty glitch? So, what type of access was assigned to the anomalous user? Yeah, that's the administrative one. Do you think it will still be? It was just on the edge here. With McSkitty. Create login profile. But we didn't get the details there, we got them here. So, here, administrator access. I think it only wants administrator access, right? Because otherwise it would have been too long. I was thinking it wanted the rest too. So, which IP does mere malware use to log in? So we just copy this one, right? Because it's the same. Which McSkitty's actual IP? Then we scroll down here, McSkitty. So 53, but before it was 31. So this is the one we want. So we'll have to type it because of the split screen. 210, 15, 79. What is the bank account number owned by Mere Malware? I don't remember that. Let's go look. So here's the very secret number of the bank account. So 2394. Let's test its smartness here now. 691277231294. I'm sure this works. No, it didn't. They've been getting better at getting the data, right? We had to add the spaces ourselves. So, want to learn more about log analysis by our own choice? No, but AWS stuff is interesting. Interpret logs from different sources. So this was very simple. I guess JQ could be used for lots of things. We're just doing JSON data here, right? So, quicker than writing a Python script to it. So this is the data we get in, and we just format it like this to start with. But there's the table. It's a table, right? We made a table once. So I'm kind of thinking, is there anything else we want to test here, right? Log universe. Yeah, I told myself I need to put these rooms into my little TSM one here. There. So I want more red days. So yeah, I think we're done. We have to click the button, of course.